Before we look at solving quadratic inequalities, let me just remind you about how we would solve this quadratic equation. We would do this by factorising, and we would get x minus 4 and x plus 3, and that would be equal to 0. This bracket tells us that x is equal to 4, and this bracket gives us that x is equal to negative 3. So these are my two answers to this quadratic equation. Now, if I was asked to sketch the graph of this equation here, I would start with a set of axes. I know the shape of the graph because it's a positive x squared, and I know that it's going to cross the x-axis at 4 and at minus 3. So it's going to look something like this. I'm now going to use these two skills to show you how to solve quadratic inequalities. This is a typical question asking me to solve a quadratic inequality. I can't find a single value for this. Instead, I'm finding a range of values. I'm going to show you how to do this using a three-step process. My first step is to factorise to get the critical values. I'll tell you what this actually means in a moment. For factorising, I put this equal to 0. So I've got x squared minus x minus 12 equals 0. Now I factorise this in the usual way, and I get x minus 4 and x plus 3, and that's equal to 0. From this bracket, I have x equals 4, and from this bracket, I have x equals minus 3. These are the two critical values. For step 2, I sketch the curve. So I want a set of axes. I know the shape of the curve because it's a positive quadratic, and I know that it's going to cross the x-axis at 4 and at negative 3. So it's going to look something like this. The final step is to use the sketch to get the answer. Remember, we're looking for where this is less than or equal to 0, so that's where the graph dips below the x-axis. So this is the part of the graph that I'm interested in, and it takes place between the x values of minus 3 and 4. So x is anywhere between the critical values of minus 3 and 4. X is greater than or equal to minus 3, and it's less than or equal to 4. This is my final answer. So to review the whole process, first of all, I write this equal to 0 and then factorise it to find the two critical values. I then need to sketch the curve of y is equal to this, so that's x squared minus x minus 12 in this case. I make sure that I mark the two critical values onto the sketch. I then look at this symbol to see whether I want the portion of the graph that's below the x-axis or above the x-axis. For this particular one, I wanted the part below the x-axis. I then use this to write down my final answer. I'm now going to change this question and see how it affects the outcome. So I flipped the inequality symbol around, and I'm now looking for the range of values for which x squared minus x minus 12 is greater than or equal to 0. Step 1 remains the same. I still factorise and get the two critical values. Step 2 is the same as well. I still want to sketch this curve, and it still looks like this. It's at step 3 where things start to change. I now want the portion of the graph that's greater than or equal to 0. So that's the parts that are above the x-axis. So that's here and here. The values of x will be this section here and this section here. Now when I write my final answer, I need to be a little bit more careful. I can see that x is less than or equal to minus 3. Or greater than or equal to 4. Notice how this time, because I'm interested in two parts of the graph that aren't joined, I get two separate answers. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. This time, it's greater than. Take extra care with this one because people seem to find these more difficult. Press pause and have a go. When you're ready, press play. Here are the answers. Now, here are some more practice questions for you. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers.